Greetings and welcome to Train Signal. You're watching Enabling Emergency Services E911 with Microsoft Link Server 2013. In this video, we're going to start off with an overview of E911 and the location information services. We'll also see how clients acquire their location information when they log in and register with Link. We'll also trace the path of an outbound call, so we'll look at the routing of E911 calls within your Link environment. Throughout the video, you're going to be introduced to the concept of an E911 policy. We're going to see how to set up E911 policies, and we'll also wrap up this video with a demonstration on configuring E911. With Microsoft Link Server 2013, we have an enterprise voice feature which is supported within the United States exclusively, and it's called E911 or the Enhanced 911 Services. E911 is an emergency dispatch feature that's designed to dispatch emergency personnel to a caller's location. So it's a location feature so that when a client powers up and they register with the Link server, your clients can obtain their location, and this is based upon something called a list services database, where we as administrators, we create what's called a wire map. We populate a database with network addresses which get mapped down to civic addresses. Your users can be identified based upon their street address, the floor level, the room number, so we can provide additional information, not just the street address. So if you happen to work in a very large organization, maybe you work in a big building in the downtown Chicago or New York, when that call comes in, the E911 services provider will be able to route that call to a local public safety answering point and dispatch the emergency personnel immediately. Microsoft started to provide E911 support back with Link Server 2010. So we have native support built into your Link 2010 clients, the Link 2010 client, the Link 2010 attendant, and also Link Phone Edition, running on your IP phones. Well, now we're up to Link Server 2013, so as you can imagine, it's also supported with your Link 2013 client. So if you have a situation where a user places an emergency call, the Link server is going to route the call, which will include the audio for the call, along with the location information and your callback identification info through the mediation server out to your E911 services provider. Your services provider then uses that location information to route the call to a local public safety answering point. And there's thousands of these across the United States. So if I place a call from Mesa and it gets routed out through a gateway or through my SIP trunk connection over in Phoenix, my client location of Mesa gets passed along with the call. So the call can get routed to a local public safety answering point or PSAP based upon my Mesa location, not the Phoenix centralized SIP trunk connection location. In order to use the E911 services feature, we have to set up the infrastructure for enterprise voice, including the call routing out through our mediation servers and our gateways. Microsoft Link Server 2013 supports a couple of methods for routing your emergency calls out to your E911 services providers. We can either use SIP trunk connections or ELIN gateways to connect to PSTN networks. With a SIP trunk connection, we would have a session initiation protocol trunk connection over to a qualified E911 services provider. In the case of a PSTN connection, we would have to use an emergency location identification number gateway, an ELIN gateway, to connect us over to our PSTN-based E911 services provider. If we're using an E911 services provider across a SIP trunk connection, we have to create something called a wire map, which is populating your list server database with network addresses which are mapped down to civic addresses. We can add different types of network addresses into our database, such as wireless access points, subnets, switches, and we can even get right down to the switch port level. Once we've provided the addresses inside of our database, we then have to validate the addresses up against a master street address guide out at the provider. This validates that the addresses that we provided inside of our database are actually known addresses. Now the validation process, it doesn't correct any problems that you have for you. So if addresses show up as being non-validated, you have to go back and fix them. So if somebody in your organization were to dial an emergency number such as 911 and the call gets routed out to our E911 services provider, if the caller has a known location getting passed along with the call can get routed over to a local public safety answering point. But if the client has a location that's undefined or that's not known or validated, in this case, the E911 services provider will route the call to a national or regional emergency call response center. And their specially trained personnel will attempt to obtain your location verbally and then route the call to a local public safety answering point. So if you don't have a known address, they're going to have to get the address from you so that they can route the call to a local PSAP. When a Microsoft Link Server 2013 client places an emergency call,
The client is going to pass along the information in regards to where the client is located. So for example, at Carve Rock Fitness, I could have a client out at Mesa or maybe the Tempe branch office. And when those clients place a call through the emergency provider, if the call were to get placed from the Phoenix or the Scottsdale office location, it wouldn't matter because the client location gets passed along with the call. And the E911 services provider would route the call to a local public safety answering point based upon where the client's located. So if I was in the Mesa office and I placed the 911 call, the emergency personnel will get dispatched out to the Mesa office, not to the Scottsdale office. If you connect over to your E911 services provider through a PSTN connection with an emergency location identification number gateway, you would still have to populate your list services database with a wire map, but you have an additional entry that you have to provide with your records. You have to provide an ELIN number for each location. The emergency location identification number, it becomes the emergency calling number during the emergency call, and these numbers have to be loaded into the automatic location identification database of your providers. At Carve Rock Fitness, voice over IP is something new to us, so as a result we still have a lot of analog devices on our network. And the problem with this is that analog devices don't have the ability to query for their location from the location information services, like your Link clients can. And they also do not have the ability to send their location information along with a call. With Microsoft Link Server 2013, we have a couple of choices that will accommodate the analog devices. The first choice can be used in environments where all of your locations have PSTN gateways and your clients are configured for direct inward dialing. In this type of an environment, you can provision the analog device location directly with the private switch automatic location identification services provider. In order to support this, when you're setting up your analog devices as contact objects, we would define policies specifically for those contacts, and the voice policies would route the emergency calls directly through the local gateway to the PSTN provider that is servicing our sites. The private switched automatic location identification services provider, they have a database at their location that maps the direct inward dialing of each analog phone to a physical location, and it provides the location that they send along to the local public safety answering point. In our second choice, if your E911 services provider supports this option, you have the ability to register analog phones' direct inward dialing numbers and their corresponding emergency response locations with the E911 services provider. So when a call comes into the E911 services provider, if there is not a known location getting passed along with the call, the provider can query up against their database to see if there's a match. The query on the database is going to look up the direct inward dialing number and to see if there's a match for a location. If they do have a match, the call can get routed over to a local public safety answering point. If there isn't a match in the database, your call gets routed over to a regional emergency call response center, and they'll verify your address verbally before routing your call over to a local public safety answering point. Now that we've had an overview on E911 and how the location information services works, let's take a look at acquiring a location and routing E911 calls. When our Link clients power up and they register with the front-end pool, the front-end pool will provide information to your client in regards to its E911 policy, and it also provides your client with information on where to connect to register with LIS, the Location Information Services. Each of the central site pools will have their own location information services. So when your client connects over to the Location Information Services, the client will provide whatever networking connectivity information that it has to the LIS server. The LIS server will query the backend SQL Server database, and it's looking for any matching records for the client. If there's a match inside of the database, the LIS server returns a location back to the client. If there isn't a match in the database, the client could be prompted for a location, and this is going to be driven by the policy and how it's configured. In our diagram, we have step number 1, which is your administrator populating the LIS server database with your wire map. You're mapping network addresses down to civic addresses. In step number 2, if we're using a SIP trunk connection for our E911 services provider, we have to verify the records in our database up against the master street address guide to verify that our records or our addresses that we're providing in our database are valid. In step number 3, we have the client registration, and this is where your client is sending over a location request to the location information server with any of the information that your client has discovered as it's powered up and registered, such as your subnetting information or the wireless access point you're connected to. If the LIS server finds a matching record inside of the database in its wire map, it sends the information back to your client in a presence information data format location object. It's an XML format. Your client will then cache that location information locally, so if your client does place an emergency call, the information gets passed along with the call.
When a client dials an emergency number, a SIP invite gets passed over to the Microsoft Lync server. The SIP invite is going to contain the location information and the caller's callback identification. The Microsoft Lync server at this point is then going to route the call based upon the PSTN usage records. So once again, this requires the enterprise voice configuration be set up within your environment, with your mediation servers and your gateways defined inside of our topology. At this point, the call then gets routed across your SIP trunk connection or your ELIN gateway through your PSTN connection. In step number 3, we can see the call getting routed out to our PSTN E911 services provider. In the case of a PSTN connection to an E911 services provider, the E911 call will get routed over to a selective router that would then perform a query up against their internal database looking for a location for the client, based upon the caller ID. If this was a SIP trunk connection, the caller location information would have been passed along with the call. You'll also notice that we have a step number 5 which has an IM notification. Microsoft Lync server can also be configured to send a notification out to a third-party SIP address, like for example an on-site security desk. So when an emergency call gets dialed within your organization, they can have a notification show up on their screen so that they know that there's an emergency call that's just been placed. The message contains the caller's name, their phone number, the time, and location. So now your personnel know that there's an emergency call being placed and they'll be ready for it. In the next example, we see routing an E911 call using a SIP trunk connection. And the diagram looks very similar in the sense that your call still gets routed through your front-end servers, out through your mediation server, and over to your E911 services provider. But this time, instead of using an ELIN gateway, we're using a SIP trunk connection. When the call gets routed out to the E911 services provider, if the location information that has been verified is passed along with the call, the E911 services provider will be able to route your call to a local public safety answering point right away. If you don't have a known address or a verified address, the call gets routed over to an emergency call response center, where they're verbally going to verify your address before routing it over to a public safety answering point that's local to you. You'll also notice at the top of the diagram where we have the one-way or two-way audio. If your E911 service provider supports it, we can also bring a third party in on an audio call, one way where they can hear the call, or two-way where we can also hear them. So if a user dials 911 within the organization, the on-site security desk could possibly listen to the call, but if the audio was set for two-way, we could also hear them, so if they needed to provide any helpful information to the responders, that's possible. When configuring E911 in the location information services, one of the things that we have to do is define location policies for our clients. Let's take a look at the settings involved with setting up a location policy. When we create E911 policies, the scope of these policies, they can be assigned globally at the site and right down to the user level. When you're applying your policies, you want to remember that with your E911 location policies, when we apply these to a network site, the network site policies will actually take precedence over user level policies. And this is intentional. And I know it's not the way that a lot of the other policies work with Microsoft Lync Server, but it's designed like this because in a lot of cases, due to compliance, we have to apply E911 policies at the locations. Or in this case, we're mapping physical subnets down to the different network sites. So if for whatever reason you had a user that had a user level policy, and there was a policy applied to the network that that client was attached to, based off of its IP address, in this case the site policy would take precedence. We're going to see a demonstration in just a moment on setting up our E911 location policies. Before we do that, let's take a look at some of the settings. Emergency services enabled. If you set this value to yes, the client is enabled for E911. Inside of the control panel, you click inside of the selection box. So when your client powers up and they register with the Lync server, your client will attempt to acquire a location from the location information services. And this also means that if your client makes an emergency call, the client will pass that location information along with the call. If your emergency services are set to enabled, we can also define if a location is required. So as an example, if a client powers up and they register with the Lync server, and there is no defined address for the client's network location, if this was set to no, the client wouldn't be prompted for a location. If the value was set to yes, the user will be prompted for a location, but they can possibly dismiss the prompt. You also have the option where you can define a value called disclaimer, and this means that your user will be prompted for a location, and they'll also be provided with a disclaimer if they try to dismiss the prompt. The Enhanced Emergency Services Disclaimer allows us to specify disclaimer that the users will see if they dismiss the prompt for a location. We also have a value for the emergency dial string. This is a normalized number minus the plus symbol that signifies that there's an emergency call for Microsoft Lync. If a client dials the emergency dial string, this causes your client to include the location and callback information along with the call. The emergency dial string mask is another option that allows me to define additional numbers that will get translated over to a 911 call or to an emergency call. This is very useful for organizations that have offices in other countries. For example, if I had somebody visiting from Rome, they're used to dialing 112 in the case of an emergency, not 911. You'll also see an entry for a PSTN usage record, and the PSTN usage records define where you can call to and the paths that your calls are going to take. For example, in our case, will the call get routed out through a SIP trunk, a PSTN gateway, or an E-Link gateway? The notification URI allows us to define one or more SIP URIs of security personnel or maybe on-site security desk individuals that get notified when an emergency call goes out. This sends an instant message over to the SIP address. We can also define a third party to get brought in on the call. The conference URI specifies a direct inward dialing number that should be conferenced when an emergency call is placed, for example, your security desk. The conferencing mode allows us to specify if the audio is one way where they can hear us, or two-way where the audio can go in both directions. We also have the ability to define what's called a location refresh interval. This allows us to define a value from 1 to 12, and this is a measurement in hours. So this is allowing us to define the number of hours in between client refreshes of their location policies. Let's take a look at a demonstration on configuring E911. In this demonstration, we're going to see how to set up E911, both from inside of the control panel and from the Lync Server Management shell. Now keep in mind before we go into the demonstration that E911 does require that you've got enterprise voice configured. I've already defined my mediation server configuration and my gateways inside of the topology builder. I've also defined my dial plans, my voice policies, my routes, and my trunk configurations. I've also set up a route for emergency calling for E911. So to start this demonstration, we're going to go into our control panel. We'll log in as the administrator. And then from inside of our control panel, we're going to navigate down to our network configuration. And at the top of the console, we'll click on Location Policy, and you can see that I have a default policy here called Global. From inside of my location policies, I can define a policy here globally. We can also apply policies at the user or the site level. If you apply a policy at the site level, you're going to see your Microsoft Lync sites, central sites, and branch sites. But keep in mind that if you create a user level policy, like for example here, I'm going to create a user level policy for Mesa. This policy isn't configured, but we're going to come back to it in just one moment. But if I click on the link over here or the tab for sites, you'll notice that I have this site called Mesa, and then underneath it where it says location policy, you'll be able to see that user level policy right there. So if a user's in a site that has a user level policy applied to the site level user policy would actually override a user tag level policy applied directly to the user. Now going back over to my location policies, let's take a look at the settings for the Mesa policy that we're defining. As you can see, my policy is called Mesa, and the scope is user mode, which again can be applied to a networking site. Not a Lync site, it's a network site for Lync. Underneath the name, we can define if this policy is enabled for E911 or not. If it is enabled, that means my clients will try to get their location information from the list server, and if they dial an emergency dial string, they'll send that location information along with the call. We can also specify if a location is required or not. We have three choices: required, not required, or disclaimer. So if a client contacts the list server and is not able to obtain an address from the list server, the client will then respond based upon how this policy is defined. We could prompt the client for an address. We can also specify if the E911 can only be used by the emergency services or if it can be used by other applications as well. Here, let me click on these selections. I'm going to enable E911. I'll provide the client with a disclaimer if they're coming in from a non-defined location. And then underneath the PSTN usage record, this will define how that call gets routed. And here I have an enterprise voice PSTN usage record called emergency calling. At Carve Rock Fitness, we're only using 911 as our E911 dial number. We don't have any foreign offices with other emergency dialing strings. But if you had a dial mask, that would be another number that also got routed, in our case, to 911. At the bottom of the console, we can define a notification URI, and that will be a SIP address where an instant message gets sent to notify something like our security desk that there's an emergency call going out. We can also define a conference URI in the conferencing mode. This would allow me to bring a third party in on the call. So here you see an example of SIP:+ followed by the telephone number at contoso.com. This would be a SIP address, again, probably used for like our security desk, so that they can be notified that there's a call going out and they can listen to the call. So the conferencing mode can either be one way where they can hear the call, so the audio goes in one direction to them, or it can be two-way where we can hear them also. So if they were to speak, the emergency responders would hear them too. I'm going to commit my changes. Let's toggle that off. We're going to commit our changes. And I now have a new location policy called Mesa, which is a user or tag level policy that's currently not being applied. Now that we have a new location policy, let's take a look at some of our command line options that we have for configuration of E911. You have to keep in mind that there's a lot of command line options that go along with the configuration of this, and we're not going to look at all the different commandlets and all the different variations to the commandlets. We're going to start off this demonstration by opening up the Link Server Management shell. The first commandlet I'd like to introduce is set-cs network site. I'm going to modify my existing site, and the identity of this site is called Mesa. We're going to define a network region ID for my networking site, so we're going to associate that networking site of Mesa with a region called Scottsdale. And we're going to identify a location policy called Mesa to apply to it. That's the user mode policy that we just created a moment ago. And you'll give that a moment. And you can see that I've now applied the settings to that policy. So let's take a look over here at my control panel. And if I open up my site called Mesa, you can see that I now have that location policy called Mesa being applied to it. Let's clear the screen. Here we have another example where I'm going to create a brand new networking site called Chandler. And I'm going to associate the Chandler network location with a network region ID called Scottsdale. And I'm going to apply the same exact location policy called Mesa. And once again, you can see that that ran without any problems. Let's clear the screen. If you're defining network locations or network sites, you also have to define the subnets that go along with those network sites. So here's an example where I'm going to create a new CS network subnet. The subnet identification is going to be 172.11.32.0, and I'm using 20 bits in the subnet mask. I'm associating this subnet with my site called Chandler. And you can see that that ran without a problem. I could also create my subnet objects from inside of the control panel. Let's clear the screen. In our next commandlet, we're going to set the CS location, which is called global. We have a location policy, the default global policy. We're going to enable the enhanced emergency services by setting it to true. The location required setting is going to be set to disclaimer. And you can see our disclaimer. Your company policy requires you to set a location. If you don't set a location, the emergency services will not be able to locate you in an emergency. Please set a location. When the call gets routed out, we're going to be using a PSTN usage record called emergency calling. The emergency dial string is 911. We also have an emergency dial mask of 112, which also gets routed over to 911. We have a conference URI, SIP:+1425.555.0123 at carverockfitness.com. We're using the location information for E911 exclusively, and the clients will update their policy every 2 hours. Let's hit enter. And you can see that we've just updated our policy without any problems. Let's clear our screen. When it comes to populating our list services database with the wire map, we can provide entries inside of the list database that will map network addresses down to civic addresses. Network addresses such as subnets, wireless access points, switches, and even getting right down to the switch port level. Let's take a look at an example of populating our list database. Here you can see an example where I'm setting a list subnet. I'm adding a subnet into the list server database on SQL. The description is subnet 1. My location is set to location 1 and the company name is Carverock Fitness. The house number is 1234. The house number suffix is null. Pre-directional is empty. Pre-directional or post-directional would apply to a street. For example, North Main Street or Main Street Northeast. Does the direction come before or after? The street name is 163rd, the suffix is Ave, post directional northeast, the city is Scottsdale, the state is Arizona. I've got my postal code and I also have my country identifier. Keep in mind that these are the mandatory attributes that you have to define with your command line, or the mandatory options. Let's run our command line and see what it looks like. And as you can see, I've just added the subnet 157.56.76.0, subnet 1, into my location database, into my list server. Let's clear the screen and we'll take a look at another example. In the next example, I want to add a wireless access point into my list server database. You'll notice the command looks very similar, but I'm using a set-cslist wireless access point commandlet, and I'm identifying the WAP based off of a BSS ID, the basic service set identifier. The remainder of the commandlet looks very similar. So let's hit enter. And once again, you can see that I've just added an entry into the list server database without a problem. Keep in mind that we also have a set-cslist switch and a set-cslist port commandlet that we can use for identifying switches or switch ports inside of our database. Let's clear the screen and take a look at a couple of other commandlets. Once you have records inside of your list server database, you would then typically verify the records up against the master street address guide. So if I have an E911 services provider across a SIP trunk connection, I have to tell my Microsoft Lync server where to connect to and how to authenticate when verifying the records in our database. Let's take a look at an example of a commandlet. In my virtual environment, I don't have connectivity to a provider right now, so I provided some sample data. Set-cs list services provider is your commandlet. You specify the services provider name, which you can provide whatever name you'd like. But what we do have to define is the validation services URL, and that's given to you by your provider. It's where you're going to connect to verify the records in your database up against the master street address guide. You also have to define your certificate file name, and then you point to the certificate file itself provided by your provider, and you provide your password. Let's clear the screen again. The next commandlet that I would use would be used to verify the records inside of my database up against the master street address guide. So now that my server knows where to connect to and how to authenticate, I would use a commandlet that looks like this. Get-cslist civic address. We pipe the results into a test-cslist civic address commandlet, and then we update the validation status inside of our database. Once we've validated all of our records, we can then publish them. Let's take a look at what that commandlet looks like. Let's clear the screen. When you're ready to publish your commands, we would use the publish-cs list configuration commandlet. And as you can see, I just published my configuration. Those entries are now available to the clients. Well, I hope you've enjoyed the demonstration, and we'll see you in the next video.